Welcome dear student, welcome to your अपना channel Physics JN, specially recognized for the joint and NEET। तो बच्चों आज हम सीखेंगे कि स्फेरिकल मिरर में रिफ्लेक्शन क्या होता है। तो स्फेरिकल मिरर क्या होता है? What is spherical mirror? Spherical mirror is a part of a hollow sphere। अगर किसी भी हॉलो स्फीयर से उसका एक पार्ट को हम निकाल ले तो वो स्फेरिकल मिरर होता है। वो स्फेरिकल मिरर का क्या होता है कि वन साइड इज पॉलिश्ड एंड द अदर साइड इज कोटेड विथ सिल्वर। इफ द इनर साइड इज पॉलिश्ड इट इज कॉल्ड कॉनकेव मिरर एंड इफ द आउटर साइड इज पॉलिश्ड इट इज कॉल्ड कॉन्वेक्स मिरर। For concave mirror, the reflection takes place in the inner side. For convex mirror, reflection takes place on the outer side. Okay. Now we go with some definition. So, if we take a concave mirror, that is this type of mirror. Okay. So if we name it as M1, M2 and take the midpoint, name it P. P means pole. The midpoint of a spherical mirror is called pole. Now, the radius of the sphere for which it is a part. इसका मतलब क्या है कि जिस भी स्फीयर से इसको हम ले आए, ये पार्ट ले आए, अगर वो स्फीयर का जो सेंटर है इसको कहता है सेंटर ऑफ कर्वेचर। इट इज डिफाइंड बाय और डिनोटेड एज सी। सो द सेंटर ऑफ द स्फीयर फॉर व्हिच द मिरर इज अ पार्ट इज कॉल्ड सेंटर ऑफ कर्वेचर। इफ वी जॉइन द सेंटर ऑफ कर्वेचर विद द पोल देन ए स्ट्रेट लाइन इज ऑब्टेन्ड व्हिच इज कॉल्ड प्रिंसिपल एक्सिस, व्हिच इज कॉल्ड प्रिंसिपल एक्सिस। क्लास 10 में आप ये पढ़े होंगे। ओके, तो हम एक बार फिर से इसको दोहराता है कि रिवीजन हो जाए। प्रिंसिपल एक्सिस। नाउ यू टेक दैट द फोकल पॉइंट। सो फोकल पॉइंट और फोकस पॉइंट is defined for both convex and concave mirror. Here we take convex mirror, so any ray parallel to the principal axis and close to the principal axis, it must be close to the principal axis, must be passed through a fixed point, must be passed through a fixed point which is called focus point. Focus. So but in case of convex mirror, it does not pass with that point. For convex mirror, if the ray parallel to the this is pole and this is principal axis, if any ray incident, suppose AO is incident on the mirror and reflected along the direction OB, then if we draw it or extend it at the back side, then it intersect the principal axis, which is called point of focus. So if we define the focus, then we can must say that if we define the focus, then we can must say that the point at which rays parallel to principal axis converge for concave mirror or appears to diverge for convex mirror. Okay, the point at which the rays parallel to the principal axis converge or appears to diverge. Here the rays parallel to the principal axis, any rays can be converge, but here the rays will appear to diverge from F. So in this both this case, F is known as focus. The distance between the pole and focus is called focal length of this mirror. The distance between the pole and focus is called focal length. It is denoted by small f. And the distance of pole and the radius of curvature, here the radius of curvature is the distance between the pole, and if here is the radius of curvature, then the distance of pole and radius curvature is known as and the center of curvature is known as radius of curvature. It is defined as r. There is a relation between f and r which we can prove later. Okay, now we go with the diameter of the mirror. The diameter of the mirror is called aperture. This is the diameter. It is called linear aperture, and this point M1 and M2, if makes angle at C, if M1 M2 makes angle at C, then it is called the angular aperture. M1 M2 is the diameter of the mirror, so it is called linear aperture. It is called linear aperture. Linear aperture. And the end point of the mirror makes angle with the center of curvature is known as angular aperture. In the ray optics, we can take the aperture as very, very small. So, if the aperture is not small, what problem will be occurred? Here we can consider that any rays parallel to the principal axis is after reflection will pass through focus F. But if suppose this is a suppose this is a mirror, concave mirror. This is a concave mirror. If the angle of incidence is very large, any rays, the angle of incidence is very large, then in case if this is center of curvature and pole of mirror M1 M2, then the line joining the center of curvature and the point of incidence O is called normal. We know that from the laws of reflection that the angle of incidence I must be equal to the angle of reflection. Okay. So if the angle of incidence is large, if angle of incidence is large, then all the rays parallel to principal axis does not meet at focus point or focus. So if the angle of incidence is large, then rays does not meet at the focus point. They can meet anywhere between P and C. Okay. So as we consider that all the rays passing parallel to the principal axis must be meet at focus, so the angle of incidence must be very small. This is P pole, this is center of curvature, and this is focus point F. Then all the rays must be close to the principal axis, and angle of incidence I must be less than 5 degree. All types of mathematical problem we can consider it. Okay. So in this case, the rays pass after reflection through the focus. Okay. If we name it A, O, B, C, D, E. Okay. And the center of curvature is this. So this is the main criteria of focus. Now what if the rays not exactly parallel to the principal axis? What if the rays are not exactly parallel to the principal axis? Then are they meet at focus or not? If you know, then okay. If you do not know, so please watch. The rays are obliquely incident on the mirror M1, M2. So if this is point focus A, pole P and C is center of curvature C. The rays AO is incident obliquely on the mirror. Then after reflection, the rays does not pass through the principal focus point. It meet at some another point F dash. If we draw a plane perpendicular to the principal axis and passing through the principal focus F, then this plane is called focal plane. This plane is called focal plane. So the ray parallel to the principal axis meet at focus, but the ray obliquely incident, that is does not parallel to the principal axis, met at some another point in the focal plane, and this is called principal focus. F is called principal focus. F dash is called the secondary focus or secondary focus. Okay, so this must be known by you before approaching any mathematical or numerical problem. Now we go with some simple numerical. अपना पेन और कॉपी को निकाल लीजिए और मेरे साथ कीजिए. ओके, सो we can go with some numerical problem. Same ray is parallel to principal axis. Suppose this is A dash is passed through a point Q. This is center of curvature C, this is pole P, and this is the normal. Okay, so this angle is incidence I, this is also I, angle of incidence equal to angle of deflection, so we can take both angle as I. Here it is said that find CQ, find the value of CQ, ear distance. Also find CQ if I tends to 0. If I tends to 0, then find CQ. So according to the question, PC must be equal to R, the radius of curvature. So A dash C also radius of curvature. Now we can draw a perpendicular from Q to A dash C. So this must be a midpoint. It is known as QN. So QN must be midpoint of A dash C. So if A dash C is R, then NC equal to R by 2. We can write it. Then from triangle NCQ, we can say that this angle is I, alternate angle, because A dash is parallel to CP. So this angle A dash C and A dash CQ are alternate angle. So this angle is I, so this angle is also I. Now from NCQ, we can say that cos I, what is the value of cos I? Cos I means this. Cos I means this is perpendicular, this is hypotenuse and this is base. So base upon hypotenuse. So R by 2 upon hypotenuse is CQ. So from here we can write the value of CQ equal to R by 2 cos I. This is the number 1 answer. CQ equal to R by 2 cos I. Now go with the second part, I tends to 0. So if I increases, cos I decreases, because with increase of theta, value of cos is decrease. Cos 0 is 1, cos 45 is 1 by root 2, cos 90 is 0. So as the value of I or theta is increased, the total value of cos theta becomes decrease. Similarly, in the reverse way, when I tends to very small, so tends to 0, we can say that cos I nearly equal to 1. So we can say that CQ equal to R by 2. So this is CQ is R by 2. The PC is R, so this is must be R by 2. So PQ is R by 2 and PQ is nothing but the focal length F. So we can say that F equal to R by 2. So all the rays parallel to the principal axis must be passed through a fixed point which is half of the radius of curvature and known as principal focus point. Okay. So this type of मैथमेटिक्स यू विल लर्न फ्रॉम हेयर. सो बच्चों आज के लिए इतना ही. इसके नेक्स्ट डे हम लोग साइन कन्वेंशन के बारे में जानेंगे और जो मिरर फार्मूला है 1/u + 1/v = 1/f वो प्रूव करेंगे. ओके. सो देखते रहिए, जानते रहिए और आगे बढ़ते रहिए. इफ़ यू लाइक माई वीडियोस प्लीज़ सब्सक्राइब चैनल फॉर more learning interesting video. Thank you very much.